Okay, so last page, page 3, is a very nice summary chart. And we're going to use this for now. This is ultimately something that you will be responsible for knowing on your own. But for now, it's great to use this chart so that our rational function end behavior can fall into 3 categories. But just by looking at the leading term, we either end up with something like a polynomial left over with some x to some power, and then we use our ideas about leading coefficient and degree. So that's the first row here, where you can see this example where it's left as a polynomial. Here we have a negative leading coefficient, which means we would be going down on the right side, and since it's an even degree, we would match going down on the left. So this is a negative LC, and then we have an even degree, which would match. So we're just building on that idea. In the second case, you could get a number where then you will just have a constant and therefore a horizontal asymptote at that number. And then lastly, we said you could be left with a rational function where you have a variable left over in your denominator, but as you start to plug in big numbers for x, that fraction is going to become smaller and smaller and smaller and smaller until you essentially just get to 0. So let's try to apply this here with a couple examples. So we are focusing on the leading term. So we're going to focus on our 3x squared and our 5x to the third. So we get 3x squared over 5x to the third. We're going to reduce these two x squareds cancel out with 2 of those x's. So we're left with, after 3, we take away, divide out 2, we're left with 1. So this is a rational function, which as we get closer and closer to 0, so this will have a horizontal asymptote at y equals 0. Because this, we have an x left in the denominator with no x's in the numerator. As soon as we make that x big, like a million, 3 divided by 5 million is essentially becomes 0. Okay, example 2, we have 6x to the fourth as our leading term over 2x. So we have 6x to the fourth and a 2x. We're going to reduce 6 over 2 becomes 3. X to the fourth divided by x, we're going to take away one of those degrees, and we're left with 3x to the third. So now we look and say, okay, we're left with a polynomial. So we have a positive leading coefficient, which should tell us our right side finishes up. We have an odd degree, which means our left side is going to go opposite. So a lot can happen in between, but ultimately a lot's going to go on in the middle, but ultimately our rational function will end with the right side going up and the left side going down. And then lastly, number 3, we're looking at this negative 4x squared leading term and this 2x squared leading term. We're going to reduce negative 4 over 2 becomes negative 2. X squared divided by x squared cancels. So we're left with a constant. So our horizontal asymptote is going to approach this y value at negative 2. So we have our 3 cases. In the first, we have a smaller degree on top, bigger degree on the bottom, always going to lead to 0. In number 2, we have higher degree on top, which is going to lead to some more complicated polynomial end behavior. And then in example 3, we have where they share the same degree, we end up with a constant, and our horizontal asymptote approaches at that y value.